fracking fluid, and there's hundreds of different chemicals in it, and it gets injected into an oil and gas well, and then it's injected under high pressure, and then it goes into all of the cracks and fissures in sedimentary rock, and that breaks up the fissures and removes if there might be oil, but there's also natural gas in here. Okay, and then that frac fluid will be mixed in with the oil and gas, and we can take all of that stuff out of the well, and then separate the oil and gas from the frac fluid. The frac fluid gets could be reused, or then eventually gets thrown into the well and stayed there because it's full of toxins, and then we can remove the oil and gas through distillation process. So essentially, the frac fluid sandblasts the well and breaks up the fissures, and we can take the oil and gas out of the cracks in the frac wells. Because there's such high pressure injected into the ground, this can cause earthquakes. And the other issue with hydraulic fracturing that people are worried about is that a lot of these fracking wells are above groundwater. So if there's big cracks, the fracking fluid or the natural gas that's in these fissures can percolate down into the groundwater underneath and then contaminate groundwater wells. So that's a big concern. But earthquakes are actually quite common with hydraulic fracturing. And obviously we're going to make combustion reactions with this, so we already talked about that, right? So think about energy conversions, right? Chemical potential energy, right? And we're going to burn that. We're going to convert it into, if it's clean, water and carbon dioxide, but we'll convert it into kinetic energy and mechanical energy. Could be sound, could be any type of energy that we need from a power source. Okay, so here's an energy conversion that's quite common, right? Our internal combustion engine. So you should kind of understand how the combustion engine works, right? There's a few of you who work on engines, so you're already familiar with how it works, right? We burn fuel, right? And we're going to convert that chemical potential energy to kinetic energy. And once we burn that energy, it expands and turns a piston, right? And the piston will ignite a spark plug because we have an air-gas mixture in there, and we create combustion. And that's what makes your engine go. Okay, so the difference in pressure when the gas is burned, it is turned into CO2 gas, and it expands. Right, the spark will ignite the oil, the gasoline in the piston chamber, and the gasoline is converted into CO2 gas. And that will expand, and that'll push the piston down, right? So this piston moves up and down, and then this moves your transmission. Okay, and that's what causes your car to work, is really just the conversion of gasoline to CO2 and the expansion and contraction of the gas in an enclosed chamber. Okay, so that's what spark plugs do. Okay, so the explosive force is from the gasoline being converted to CO2 with the spark plug. So there's this tiny fire in here, actually, right? That will push the piston down, and then that will move your engine. And the CO2 is moved out as exhaust. Okay, so I'm going to leave that there. We have this heat of combustion that I'm going to discuss in another lecture. I'm going to get into some more equations in the next lecture, but this is a good introduction to what you need to know for this unit. So you can get started on that booklet when you're ready to do it. You have about a month left until the end of school, so there's lots of time to get this done. I will be posting the rest of the lecture series for the last unit probably in the next week. We will talk to you later.